Hello everyone, this is Venma Pehan. Today we are going to talk about the subnet calculation. Actually, this is a pretty handy skill for anyone working with network or cloud platform like AWS. For beginners, I think it's easy for us to follow the simple steps, so even beginners like us can follow along. Let's start at the beginning, figuring out the IP addresses class. All you have to do is check the first number or octet of the IP addresses. If it's between 1 to 126, it's class A, or 128 to 191, that is class B, and 190 to 223 is class C. The higher ranges are for special uses, so we will skip those for now. So if we have 192.168.18.0, the first octet is 192, which puts it in class C. I hope you understand how to identify the classes. So let's move to the example. We have got the IP address 192.168.18.0. Since the first octet is 192, that is class C address, and its default subnet mask is 255.255.255.0. It's tricky to say, tongue twister. So you can say it like the /24. This is a CADR notation of subnet mask. So now say we want to split this network into 8 subnets. To do that, we borrow 3 bits, which gives us a new mask like /27 or 255.255.255.224. That gives us a block size of 32 addresses per subnet and 30 usable host addresses in each, since the first and last go to the network and broadcast. We will see it on later. So going deeper, so what's really happening with that subnet mask? When we say /27, that means 27 ones in binary for the mask. We have 27 ones in the binary form, and the rest as a zeros. Each group of 8 ones gives you a 256. You can see it here. Let's assume each octet has a A, B, C, D. I mean A, B, C, D. So now let's start calculate for A. To find the subnet mask, you have to memorize these numbers with order 128, 64, 32, 16, 8, 4, 2, 1. So you have to multiply it, these numbers, I mean the first octet ones. 1 into 128, 1 into 64, 1 into 32, 1 into 16, 1 into 8, 1 into 4, 1 into 2, and 1 into 1. So to add this number, you will get 256. So octet B and C also have 8 ones. So A is equal to B is equal to C is equal to, C is equal to 256. Now let's calculate octet D. Octet D has 3 ones, 5 zeros. So it's easy to calculate. 1 into 128 plus 1 into 64 plus 1 into 32. The rest is 0 at anything, 0. So you will get 224. This is how you get your subnet mask. I mean the /27 is equal to 256.256.256.224. Now to figure out the block size, I mean block size means usable networks in each subnet, you have to minus 224 from 256. I mean look at the octet where the mask is not 255. Here you can see the last octet is not a 255, right? So subtract that octet from 256 to get the block size. So 256 minus 224 is 32, right? So each /27 subnet starts at multiples of 32. You can see here 0, 32, 64, 96. This is a multiples of 32, right? 128, 160, 192, 224. Each is a network address for /27 subnet. Okay. Here you can see how to actually that is I teach you for example, but this is the right one method, because we get wait yeah, actually we get a 32 block size, right? So the real block size, to identify the real block size, there is a formula. Block size is equal to 2 power host bits. Host bits means nothing. /27 means 1110000, that is 224, right? Here you can see 3 ones and 5 zeros. The 3 1 means network bits. The 5 zeros means host bits. You can see the previous slide. Ones in binary is network bytes, zeros in binary is host bytes. So the formula is block size is equal to 2 power host bytes. Host bytes is 5 zeros. So 2 power 5 is equal to 32. Okay. So usable host per subnet is equal to 32 minus 2. That is equal to 30. Because these two networks are allocated for broadcast and network. Yeah, we already told you that since the first and last go to the network and broadcast. So the usable host per subnet is equal to 30. The total addresses is equal to 32 minus 1 for network and minus another one for broadcast. Now it's 30. So let's break this out, the calculating ranges. The network will start at 0, then 32, 64, 96 and so on, all the way up to 224. So if we take the first subnet, just take it, 192.168.8.18.0/27. The usable addresses from .1 to .30, and the .31 goes to the broadcast and .32 goes to network. The next subnet starts at .33 to .62, and with .63 as the broadcast address and the .64 is network. You just keep repeating until you run out of 255. So in the example, we have neatly split our network into a subnet, which within its own range, right? So I think it's easy, but sometimes without practice it's a little tricky. First, why we need to care about the subnetting, right? Because it helps us cut a large network into smaller ones. That means more control, better security and easier management. You will use this in the real world anytime you want to break up a big network, maybe to separate departments or to set up different sections in your home lab or AWS environment. Here we have reached the conclusion part. Okay, subnet calculation is a key networking skill. It let us break down big networks into smaller chunks, which makes things more secure and efficient. And with a little practice, it's really not that tricky. Believe me. Thank you.